Okay, I'm back. I wanted to break this presentation up into two because I was concerned that I was going a little bit long, so I was also getting tired of hearing my own voice. So when we left off, we were on somewhere in the middle of the long chapter 6, and I'm going to break this PowerPoint for chapter 6 into a part 1 and part 2 so you can kind of break the monotony of hearing my voice, and I'm sick of listening to myself talk as well. So I'm going to take off from where I left off looking at the cloud classification chart based on looking at clouds and how their names are identified by ranking clouds or classifying clouds by the altitude in which they form and also by the shape in which they take. And in summary, you got your lower level clouds below 2,000 meters or 6,000 feet. These tend to be the clouds with the most amount of humidity, closer to the ground with more warmth. And as you move up into the atmosphere to the middle, into the upper level, you get into cooler environments where clouds hold less water in cooler environments. And that's why the clouds substantially do start to look so differently as you move up vertically in the atmosphere. So we'll start going up through the slides now again and kind of proceeding on. And I'm going to go back one. The next chart is just a nice summary chart that I would look at, and it kind of gives you a description of all the clouds and the high clouds, the middle clouds, and the low clouds, and the clouds that are so tall that they form low and extend across all three altitudes. And it tells you a little bit about the personality and what these clouds tend to produce in terms of weather. It's a nice little chart kind of organizing everything you need to know about all the clouds and their behaviors. And the clouds that are the most interesting to me are the clouds that cover all atmospheric altitudes. And these clouds with vertical development are the ones that we typically focus on when we get interested in studying severe weather. And the ones with the word nimbus in it are the ones that are the most interesting from a standpoint. They tend to have the most moisture in them and are more likely to produce rain. Notice that the very high level clouds in summary often are made up of all ice and they have very little water content and very often are not associated with producing any types of measurable precipitation. So they give you some nice pictures about like high level clouds here with the cirrus clouds and then your middle level clouds, and the word alto is used because in Latin it literally means middle. So alto stratus literally means middle flat cloud versus alto cumulus means middle cloud that's vertically developed. The low clouds are the ones that are obviously the most interesting to us in meteorology because these are the clouds that are closer to the ground, and they tend to be the warmer clouds, and they tend to hold the most moisture and tend to be the clouds that have the best chance of producing cloud droplet growth that produces precipitation, which will be a topic more of chapter 7. And so a couple of nice pictures of the different clouds. And then we get to the clouds with vertical development, and you start to see the cumulus clouds starting to billow up. And then we see cumulus clouds towering into thunderstorms. And we see that these cumulus clouds often form in zones of unstable air, which we've talked about earlier, where we see pockets of air that are warmer than the air around it. So notice that we see unstable air producing what are developing cumulus clouds, where in a zone of subsidence, or what we would call later is a zone of high pressure with the air pressure and winds unit coming in unit 3, where we see sinking air, we see clear skies, and where we see rising columns of air or unstable air, we tend to see cumulus clouds growing. The most famous of all the cumulus clouds and unstable air is the classic cumulonimbus cloud, and we see the classic anvil shaped, and the top of the cloud is butting up against the bottom of the stratosphere, and we can see a temperature inversion is actually capping in the cumulus cloud and its unstable air, and you could see the picturesque sort of anvil at the very top, and this will be the focus of understanding this cloud when we talk about severe weather in Unit 4. starting with some continuing slides, they do get into some very obscure or yeah, some very rare types of clouds, which we won't spend much time talking about. So I want to advance these slides. And you could see here, these slides here have lenticular clouds, banner clouds, noctilucent. These clouds here will not be discussed. These generally high-level clouds are clouds that we don't spend a great deal of time with. They don't produce a great deal of precipitation. And they talk about symbolism of how we use symbols to classify whether we have clear or scattered clouds and the different types of coverage it is required to be classified as clear skies versus overcast skies. And there will be very few questions about this topic on the test. One of the exciting things that we will see more later on in the course is our ability to understand clouds by satellites and using satellite technology to understand the behavior of clouds and how we measure the behavior of clouds and classify them from space. We now have the ability, using different wavelengths of electromagnetic radiation, we could actually look at cloud cover over the United States and kind of determine which ones are stable or unstable by looking at the type of heat or radiation those clouds are releasing. So we have specific satellite programs that now are targeted to look at the Earth. One of them is called GOES. In particular, GOES, and they have a fascinating way of looking at clouds, and the one I'll talk about here in depth is the cloud here, number C, is a fascinating way of understanding cloud behavior. Color and enhanced infrared. We're literally able to look at which clouds have the most water in them by how much heat they release. And so the areas of orange and yellow indicate clouds that are releasing much more heat, which tells us the clouds that are more likely to be unstable. So we could see off the coast of California here, we could see a storm system approaching with clouds releasing vast quantities of stored heat and calories, where these blue clouds over the United States are less likely to be unstable and more likely to be stable because they have a lot less water and stored heat in them, and they're probably more likely to be flat and stratus. So literally we can see developing or developed cumulus clouds or cumulonimbus clouds, and we can see where the stratus and stable clouds are. And so now we have state-of-the-art weather technology from space that allows us to monitor and observe weather and forecast weather in ways to understand the moods of humidity levels in the atmosphere and cloud development. And this is just a new approach and new technologies we're using, and we'll see more about this in later chapters as we get into weather forecasting. That is the end of chapter 6, and again, a very complicated and long chapter, and hopefully you will see and understand a little bit more of what goes into cloud element and why clouds look differently and why they behave differently, all relating to stability or instability and how much water vapor they contain, and whether clouds are tall, cumulus, unstable, or clouds are flat, stratus, and stable, and how these clouds all tie together producing our weather and the unpredictable nature of weather, in particular in the Midwest where we live.